Welcome to the 54th lecture of Digital Electronics. In this lecture, we will be dealing with 4x1 multiplexer. First one is 4x1 multiplexer, or you can write as 4-line multiplexer. Second one is 8x1 multiplexer, or you can write it as 8-line multiplexer. Now coming into 4x1 multiplexer, 4x1 multiplexer or 4-line multiplexer. Now to draw the block diagram of a 4x1 mux, it has 4 inputs. D0, D1, D2 and D3. There are 4 inputs and 2 selector switches, S1 and S0. There are 2 selected switches. This is a 4x1 mux and the output is Z. Now if you are drawing the truth table, of this 4x1 mux, it will look like this. Okay. Now here you have selector Z. So S1, S0. Okay. You have 0, 0, 0, 1, 1, 0, 1, 1. If 0 and 0 comes, D0 will be selected. If 0 and 1 comes, D1 will be selected. This is D2 and this comes D3. Therefore, the expression of Z, you can write it as S1 bar, S0 bar, D0, or S1 bar, S0, D1, or S1, S0 bar, D2, or S1, S0, D3. That is, if S1 is equal to 0 and S0 is equal to 0, what will be Z? Z is equal to 0 bar dot 0 bar dot D0, or 0 bar dot 0 dot D1, or 0 dot 0 bar dot D2, or 0 dot 0 dot D3. So what will be the result? It will be D0. It will be D0 only. Okay. Similarly, you can take the case of D1, D2, and D3. I am not writing all the cases, but I am that is already evident from the truth table. Now let me draw the logic diagram of it. So what is Z? Z is S1 bar, S0 bar, D0, or S1 bar, S0, D0, S1 bar, S0, D0. Sorry, that is here you have D1. Okay. D1, or S1, S0 bar, D2, S1, S0 bar, D2, or S1, S0, D3. Here D1, D2, D0, D1, D2 and D3 are inputs. S1 and S0 are select inputs. So what you have is, first you have inputs, that is D0, D1, D2, D3. Now comes select inputs. Select inputs are S1, here you have S1 bar. Now S0, here you have S0 bar. Now what is the first input? S1 bar, S0 bar, D0. So D0 is, we are having an AND gate here. S1 bar, S0 bar, and D0. So here you will get what? Here you will get, okay, here you will get the first input. Yeah. Okay. Now next one is what? Next one is again you are having an AND gate. D1, S1 bar, and S0. D1, S1 bar and S0. Okay. The second term. Third term is we are having D2 as an input. D2, S1, S0 bar. that is coming here. So this one is S naught bar. Okay. So that is next input. Next one is S1 S naught D3. This D3 is coming in here. S1 is here, and S naught is going here. We can take it from here. Yeah. Now if you are ORing these four combinations, you will get this. Okay. So this is S1 bar S0 bar D naught, or S1 bar S naught D1, or S1 S0 bar D2, or S1 S naught D3. That is Z. So here what we get is S1 bar S0 bar D naught. Here what is S1 bar S0 D1. This S1 S0 bar D2. This is S1 S naught D3. So this is the basic logic diagram of a 4x1 multiplexer. Okay. Now coming into next one. Next one is 8x1 mask. Next one is 8x1 multiplexer. Okay. Or we can write it as 8-line multiplexer. Okay. So here if you are drawing the block diagram, okay, you will have 3 selector switches. For 8x1 multiplexer you have 3 selector switches. So first I will draw the truth table, then I will draw the block diagram. Truth table, 8x1 means you have D0 to D7. So output is at D0, D1, D2, D3, D4, D5, D6 and D7. Now coming into selector switches, okay, you are having S0, S1 and S2, D1, D2, D3, D4, D5, D6 and D7. Okay. So 0 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0, 1 1 1. Therefore the expression for is that, okay, these where here D0, D1, D2, D3, D4, D5, D6 and D7 are the 8 inputs. There are 8 inputs. Okay. Now how to write the expression for Z? Z we can write it as S0 bar, S1 bar, S2 bar, D naught, or S0 bar, S1 bar, S2, D1, or now for D2 it is S0 bar, S1, S2 bar, D2, or S0 bar, S1, S2, D3, or what is D4? It is S0, S1 bar, S2 bar, D4, or what is D5? S0, S1 bar, S2, D5, or what is D6? You have S0, S1, S2 bar, D6, or what is this one, 7th one? What you have is S0, S1, S2, D7. Okay. So this is the expression for 8x1 mask. Now to draw the logic circuit of it, you have, okay. So first I will draw the selector switches. S0, S0 is there. Here we are having S0 bar. So this is S0. This is S0 bar. Now comes S1 and S1 bar. So here what we have is S1, and this is S1 bar. Now coming to S2. Okay, that is S2 bar. So here you are having S2 and this is S2 bar. Now coming to first element. So again, how many AND gates you have? You have 8 AND gates. Have 8 AND gates. 1, 2, 3, 4. I will do it once, one by one. It will be easy. Now what is the first one? First one is, so we have 3 on this one. How much inputs? D0, D1, D2, D3, D4, D5, D6 and D7. There are 7 inputs. Okay. Now what is the first one? To get this D0, what should be there? This is S0 bar, S1 bar, S2 bar, D0. Okay, that's the first one. Okay, now here you will get D0. Now coming into second term, that is not D0. You can submit that, not directly D0, for that combination. Now comes 1. How to take 1? 1 means S2 is high. Okay, S2 is high, all others are low. S2, S1 bar, S0 bar and D1. Next output. Now what is S2? S2 means only which one is high? S1 is high. S1 is high, S2 is low, S0 is low, S0 is low, and there we will get D2. We will get D2. Right? Oh, 1 second. Let me redraw this figure because this will take to get congested. So I try to redraw the figure. Just redraw the figure in another part, because if you are drawing it, because redraw the figure in a different track. What I will do is, now okay. So what we have is D0, D1, D2, D3, D4, D5, D6 and D7. So D0 is there. This is D1, draw like this. D2, D3, yeah, D4, D5, D6 and D7. Now we have is, now what we have is S0, S0 and its bar. Let's take some more length. This is S0 bar. Now there is S1 and its bar. Which will take again a bit time. Okay, but I will share because it is a very big circuit. I will try to draw it with another thing. Draw it with the other example. So how to draw it? 1 second. We are having D0, D1, D2, D3, D4, D5, D6 and D7. Okay. Now what I try to do is, okay. So we have selector switches only first. So S1, S1 is there. We'll draw like in this way. This S0, S0 bar, S0, S0 bar, S1, S1 bar. So we have S1 and S1 bar. This is S2. This is S2. S1 what we have is S2 bar. Okay. Now first you need to have D0. What is D0? D0 is S1 S0 bar, S1 bar, S2 bar, D0. So S0 bar, S1 bar, S2 bar, and what you have is D0. Okay, D0 we can give it as here, no problem. Okay. Now coming into next one. Next one is 0, this one, right? 0, 0, 0, 1. So S0 bar, we're having an AND gate here. S0 bar, S1 bar, S2, and here what we have is D1. Next one is D2. Okay. That is, what is D2? S0 bar, S0 bar, S1, S2 bar, and comes D2. Next is D3. What is D3? D3 is 0, 1, 1. So S0 bar, S1, S2. This is D3. Now comes, this is D4, D5, D6 is input here, and last one what I have is D7. Okay. So what is D4? D4 is 1, 0, 0. So S0, S1 bar, S2 bar. That is D4. What is D5? 1, 0, 1. That is S0, S1 bar, and S2. Okay. Now this D6. D6 is 1, 1, 0. That is S0, S1, and S2 bar. Okay. Next one is 1, 1, 1. That is S0, S1 on input, and S2. Now if you are ORing these 8, we are ORing these 8 input. What they are getting is this. Okay. So this is basically an 8 by 1 multiplexer. Okay. So here what I have realized is 8 by 1 multiplexer. Okay. So hope you have understood the circuit of this 8 by 1 MUX. Okay. Now in the next lecture we will be dealing with okay, now one more thing. Now here we have dealt with 4 by 1 MUX as well as 8 by 1 MUX. Now one question, can we realize this 8 by 1 MUX using 4 by 1 MUX? Okay. So next heading is 8x1 maths using 4x1 maths, whether it is possible. Okay. So let me write the function table or two table of 4x1 maths. Function table of 4x1 maths. Okay. So 4x1 means you have outputs as that is D0, D1, D2, D3, and there are two selector switches. Selectors are, you can have S1 and S0. S1 and S0 are two selectors, so you have 0, 0, 0, 1, 1, 0 and 1, 1. Now if I am writing the function table of 8x1 maths, let us check how it look like. So you are having selectors. So selectors will be, you have S2, S1 and S0. Now what is the output? Z. Output is Z. So you have D0, D1, D2, D3, D4, D5, D6 and D7. Okay. Now this will be 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, that is for D4, 1, 0, 1, D5, D6 is 1, 1, 0 and D7 is 1, 1, 1. Now if I am dividing it into 2, okay, and taking this S2 as a common selector. So here what is the value? S2 is equal to 0. Here S2 is equal to 1. Okay. Here when S2 is equal to 0 and I am keeping a 4x1 maths, then I will get from D0 to D3. And similarly, keeping x2 is equal to 1, and in that if I am keeping a 4x1 maths, then I will get from D4 to D7. That means actually there are three selector switches, and in that one of the selector switches is used to select the 4x1 maths. Okay. So if I am drawing the figure, okay. So here I am having a 4x1 maths. Okay. 4x1 maths. So first I am having D0, D1, D2, D3, D0, D1, D2, D3. Now here which are selector switches? I have three selector switches, right? S2, S1 and S0. So this is S2, S1 and S0. These are three selector switches what I am having. Or I will give the input like this. Okay. I am having S2, S1 and S0. Okay. Now this is the case with this S2 is equal to 1. So what I am getting the output? When S2 is equal to 1, if S2 is equal to 1, I am getting it as D4, D5, D6 or D7. So when S2 is equal to 0, what happens? You should make a NOT gate in between here. You should make a NOT gate in between directly to S2. That is when I am making a NOT gate. I am making a NOT gate. When S2 is on, or when S2 is equal to 0, what happens? This will be get triggered. Or when S2 is equal to 1, what happens? This will get triggered because it is basically a NOT gate. Now coming into this one. Okay. Now coming into next one, that is when S2 is equal to 1, which needs to be triggered. When S2 is equal to 1, which needs to be triggered is this one. The next 4x1 maths. Okay. That is this is 4x1 maths. Okay. Here the inputs are D4, D5, D6, D7. Okay. Here what happens? One of selector is S2. Okay. S2 is given directly here, S1 is also given directly, and S0 is also given directly. Okay, so here you have one output, here you have another output, so you have to OR these two outputs, then you will get Z. Okay, because if you are having okay, that means if you are having the output of a 4x1 maths, you can write it as you can write the output as, okay, if it is a 4x1 maths, you can write the output as Z is equal to, first 4x1 maths, the output is Z is equal to S2 bar is fixed, S2 bar D, so that is S1 bar S0 bar D naught, or S2 bar S1 bar S naught D1, or S2 bar 2, that is S1 S naught bar D2, or S2 bar S1 S naught D3. Okay, that is for this 4x1 maths. So 4x1 maths number 1. Now for the 4x1 maths number 2, number 2, there we can write Z as, for number 2 we can write Z as, you will get S2, yes, you will get S2 S1 bar S0 bar D4, right? Yeah, this S1 bar, yeah, S2 S1 bar, okay, or S2 5, that is 1, so S1 bar S0 D5, or S1 is S2 right, S2 S1 S0 bar D6, or S2 S1 S0 D7. Now if you are having an 8x1 maths, if you are having an 8x1 maths, it is basically the combination of these two expressions. Okay, that means you should OR the output of the first 4x1 maths and the output of the second 4x1 maths. Okay, so hope you have understood the concept of the realizing 8x1 maths using 4x1 maths. Okay, now so that is all with this lecture. So in this lecture, where we have studied is what is a we have started with what is 4x1 maths, realized a 4x1 maths, then after that 8x1 maths. Okay, we have realized again we have realized an 8x1 maths, then we have realized an 8x1 multiplexer using a 4x1 multiplexer. Okay, so that is all with this lecture, and in the next lecture we will have this 16x1 multiplexer and how to realize it using 8x1 multiplexer, etc. Okay, so thank you, and hoping you all be there for the next lecture. Thank you.